Hi, everybody.
Hey.
Hi, sugars. Hello. Go ahead, say hi. I know you want to.
Do your gang sign.
Murder
business.
Seth wants to say hi. There we go. All right, here we go.
Business.
Okay, you have two separate sheets in front of you. We're going to do some examples off of this. I'm going to show you how to fill out this sheet, and you have notes on it, some steps. All right, here we go. Ready? Get this out. I'm going to give you an idea of what we are doing today, okay? We're going to look at this. This is called rational functions. Let me see if I can move you up just a little bit to see if you can see the paper. Sorry, sugars, sorry. All right, that's good. All right, here we go. So today we are graphing something called rational functions. Rational means ratio. Ratio means fraction. If you have a fraction, it's going to look a certain way. So we know that y equals mx plus b is a line, right? And a line looks like that. We've done a bunch of other graphs too, right? But we've never done them where we have like, ooh, x is in the top and bottom. We have an x in the bottom. We have an x in the top and the bottom. I mean, these are all crazy, right? So we're going to learn how to graph these today. It is not bad. You're going to follow the steps along, okay? But they could look like this. They have a leg here. You might have something here. Then you have something else here. So you don't know going into it exactly what it's going to look like. So I'm going to show you the steps of where we go so that we can learn how to graph the function and know all the characteristics at the same time. It's not hard. Follow the steps, okay? All right. So here's the issue with having a fraction, a ratio. There's a certain x that is not allowed to be in the denominator there.
Which one?
It's illegal.
Negative x?
What number can I not plug into the denominator?
X. 3. 0.
3.
3.
3.
What?
Why can't I plug 3 in the denominator?
Because it's already plugged into the...
Because 3 minus 3 would give you
3.
0.
0.
Can you divide by 0?
No.
Can you have a 0 in the denominator?
No.
So that creates an issue. And when you have an issue, we have to somehow document that on my graph. And that's where something called an asymptote comes in. It is an imaginary line that I'm going to get really close to 3. But boom, I can't hit 3. Okay? Because 3 is an illegal number for that function. So I'm going to put a line there and say, oh, you cannot go that far. You can go, but you got to go this way, right? You can't run into it, so you got to go, all right? So you're going to have this imaginary line. It's called an asymptote. You're also going to have something called holes. So make sure that you know the difference between your asymptote and a hole in the graph. You've got to know those, okay? So we're going to go through those and rock it. Are y'all ready? Here we go. All right, so first we're going to talk about how do you get a hole in your graph, okay? A hole in the graph happens when something cancels. So get ready, take some notes. We're going to kind of go back and forth. So when a factor, something in parentheses, cancels on top and bottom in the numerator and denominator. All right, so when a factor cancels on the top and the bottom, then you'll have a hole there. It doesn't just poof go away. Something on the graph has to show that that was there, okay? So when a factor cancels on the top and the bottom, okay? So now how do you find it? You are going to factor and cancel. So your first thing you always want to do is factor. We've learned that along the way, but you're going to factor and cancel. All right, so look right here. Look at this example. Does it look like it's already factored, or can I factor it further? What can I factor it further? Or is it look like it's in factored form? Yeah, it is factored. So look at this right here. Do you see how there's an x minus 3 on the top and an x minus 3 on the bottom? Oh, poof, those cancel. So I'm going to cancel those, but that means that I have a hole at, now look what you have to do. You have to set your factor equal to 0, and that's where your hole is going to be. So I'm going to set x minus 3 equal to 0, and I get x equals what? 3. So I have a hole at x equals 3. So you just have to set your factor equal to 0. And I'm going to have a hole at 3. Now, I know that doesn't mean a whole lot for you right now, so I'm going to show you an example. Okay?
So
Oh, never mind.
Now look. Ready? Hi-ya! When I cover that up, look. When I cover that up, all I'm left with is y equals x plus 2. What is that the equation of? Y equals x plus 2?
It's a whole bunch of stuff.
It's a line. Isn't y equals x plus 2 a line? It's a line. It's no longer a rational function. It's no longer a ratio. It's no longer a fraction. I got rid of the fractions, and all I'm left with is y equals x plus 2. So I can graph that, but guess what? There's going to be a hole at 3. Okay? So now let's go do an example of that. So get out your notes and turn to number 3. Turn to number 3 in your notes. All right, turn to number 3 in your notes. All right, so number 3, we're right here. So the first thing I have to do is factor. Is there anything right there that looks factorable? What is it? Is there something that can be factored there? Somebody say something. What is it?
X plus 1, x minus 1.
There you go. That is the difference of two squares. So I'm going to rewrite this as y equals, and in the top, that is x plus 1, x minus 1. In the denominator, x minus 1. All right, does something cancel? Absolutely. So this factor and this factor are going to cancel out, which means I have a hole at x equals 1. So over here, I have a hole at x equals 1. Now, what is left over? So I'm going to come over here and I'm going to highlight what is left over. The only thing that's left over is y equals x plus 1. And all that is the equation of a line. So all I have to do now, it's no longer a rational function. I got rid of the denominator, right? So all I have to do now is graph y equals x plus 1. All right, how do I graph y equals x plus 1? How do I graph that? It's a line. I have a slope of 1 over 1, and I have a y-intercept of 1. What do I graph first? Y-intercept. So y-intercept is 1. Oop, got to use a pencil because I've got to erase. And then I'm just going to go up 1 and over 1, and up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. All right, and I have the equation of a line. I'm using a pencil because I have to erase. All right, but this line is not showing my hole yet, so I need to go and graph my hole. Where is my hole? Yes.
Can we get a ruler?
Yes, absolutely. Go grab a ruler. Yes. Here's one.
Thank you.
All right.
Yeah, go get you.
All right, hurry up. Let's go. You're not going to really need a whole lot of it, so let's go. All right, so right here, y'all, I graph the line y equals x plus 1. Are you with me? But I have a hole. At x equals 1. So this is what I have to do. Watch this. This is your first time seeing it. Right here, eyeballs. Y'all sit down. Okay. I'm going to go to where x equals 1. Is this where x equals 1? Yes? And then I'm going to go find my graph. And right here is where I need to put a hole. So I went to x equals 1, because that's what it is. And then I went and found my graph. Right there. So I'm going to erase. And it looks like it's happening at like 1,2, doesn't it? Right there.
What's that smell?
And that should be an open hole at x equals 1. And it actually ends up being like x equals 1, y equals 2, doesn't it? It's like 1, 2. That's what it looks like there. So there's a hole in the graph, okay? There's a hole in the graph. So that's how you graph this style. There's about 5 different styles, and we're going to cover about 2 or 3 of them today. That's it, okay? That's one of them. What happens? I factor, I cancel because I have a hole, I'm left with a line, okay? All right, so I'm just going to put this over here. You have no vertical asymptote. You have no horizontal asymptote. Your domain and range are all reals, but x can't be 1 and y can't be 2. Now, where in the world did 1 and 2 come from?
The hole.
The hole! That's the one place that was illegal on our graph, was that hole right there, okay? So I got the 1 from this, but then I noticed when I traveled, I went over 1 and I had to go up 2 to get to that place. So I knew that that was y equals 2. Yes?
Is that VA and XA always going to be done?
Vertical asymptote and horizontal asymptote, no, just on this type. There's about 5 types. This is type number 1. We're going to follow the graph and keep going. Yes?
If there's a hole, is there a vertical asymptote or whatever?
Nope. Nope. You're about to see. Or you could have a vertical asymptote and you could have a horizontal. But this style, out of the 5, this is the first style I'm showing you. There are a lot of different styles about to happen. You can have a hole, you can have a vertical asymptote, you can have a horizontal asymptote. You can have the whole shebang. But I'm starting out with the easy stuff. Are y'all good? All right, so keep following me. Now, this is what you're going to do. Get back to this little piece of paper here that says rational functions. Get back to it. Come on, find it. And flip it over. All right, step number 1 says, these are your steps. Took me 16 years to come up with these steps. Factor and cancel if possible. If a factor cancels, there's a hole in the graph. That's what we just did. That is your first step. That's your first step. All right, now we're going to move on to step number 2 that talks about vertical asymptotes, okay? We're going to move on to step 2, which talks about, like I said, vertical asymptotes. Are y'all ready? All right, flip it back over. So just follow those steps. Step number 2, a vertical asymptote. How to recognize that you have a vertical asymptote, which is an x equals. If you have an x in the denominator, then you will have a vertical asymptote. So if there's an x left in the denominator, which we didn't have on the last problem, I canceled out my fraction. But if there's an x in the denominator, then you have a vertical asymptote. And this is what you do. You set your denominator equal to 0 and solve for x. And you can have several vertical asymptotes. Just depends on what's in the denominator. All right, look right here. Vertical asymptote. Set your denominator equals 0 and solve for x. Let's try it. You ready? Look at this denominator. What is that? Difference of 2 squares. So always factor if you can. Okay? That's step number 1. Always factor if you can. On this one, it's just going to be x minus 2x plus 2. Y'all good so far? Difference of 2 squares? Now set them both equal to 0. It says set denominator equal to 0 and solve for x. So set this one equal to 0 and set the other one equal to 0. So what do you get for your answers? X equals positive 2 and x equals negative 2. So I have 2 vertical asymptotes in that problem. Insane. Sorry, you can't see that one. So I have 2 vertical asymptotes in that problem. If I were to graph this, y'all, it would look something like this. I would go to positive 2, nee, 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 nee. I would go to negative 2, nee, 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 nee. And then I could continue my problem. But that's what it would look like. Those are 2 illegal values. I can't plug a 2 in there because it would give me a 0 back. Can't have 0 in the denominator. If I plugged a negative 2 in there, I'd get a 0 back. Can't have it in the denominator. Okay? It's an illegal location. You cannot go there. Hi, y'all. Stay away. Okay? All right, so we're going to have some asymptotes there. Now, flip it back over. Flip it back over. Step number 2 says find your vertical asymptotes. That's your next step. So first you're going to look for a hole. Then you're going to set your denominator equal to 0 and solve. Okay? And those are your vertical asymptotes. All right, how are we doing so far? Kind of crazy, right? All right, the next thing we're going to do, and I don't have an example just strictly, well, I could do a little bit of an example of that. Go to your notes. Go to your notes. And let's do number 2. Look at number 2. All right, so our first step always, so number 1, we need to see if anything cancels. Look for a hole. So factor and cancel. That's your step number 1. Look for a hole. Are y'all okay? What are we looking at?
No.
We're having a hard time? Okay. All right. All right, so find a hole. Is there a hole in this graph? Even if I were to factor, I can take a 2 out of the top and get x minus 3. Is that going to make something cancel? Does anything cancel? Do I have a hole? Do I have a hole then? No, nothing cancels, so no hole, okay? So nothing cancels, no hole. All right, done with step number 1, and you got to use we have a lot of stuff to do here. All right, step number 2 is to look for your vertical asymptote. How do you find your vertical asymptote? Set your denominator equals 0, okay? Have this sheet out with the steps right next to you. So you're going to set your denominator equal to 0. So let's do that. Which one's my denominator? X minus 1 equals 0, so x equals what? 1. So I have a vertical asymptote at x equals 1. So I'm going to take my colored marker or whatever you have there to help you out, and I'm just going to draw a dotted asymptote at x equals 1. So this is where x equals 1, right? Y'all see my little line there? You're going to make a vertical line through x equals 1. These are all the places where x equals 1. Good. All right, did we have a hole in the graph? No. So over here, just put none. There's no hole in the graph. All right, are we good so far? I can't go any further because I haven't taught you any further. So now let's go back and find out, how do I find a horizontal asymptote, okay? So go back to your steps, step number 3. This is so important. And we're really only going to look at one of these today, so pay attention. All right, to find your horizontal asymptote, you have to look at the degree of the numerator and denominator. That's a lot of words, but simple. What is a degree? The exponent, thank you. You're on fire. So look at the exponent of the numerator and denominator. So I want you to look at the exponent of this numerator and denominator. Look at it. What are they both? X to the what? X to the first power, right? That's 2x to the first power, that's x to the first power. Do they have the same degree, the same exponent? Yes. So I'm going to look at this. Is the degree of the numerator less? No. Is the degree of the numerator equal? Yes. This is the one that I'm looking at. The degree or the exponent of the top is the same as the exponent of the bottom. They're both 1, right? So this is what I do. My horizontal asymptote is going to be the leading coefficient of the top over the leading coefficient of the bottom. What is a coefficient?
The number that doesn't change.
A number in the front. So check it out. Right here, these are my leading coefficients right here.
1 and 2.
2 and 1. That's right. So my horizontal asymptote, so come down here. Now we know how to find my horizontal asymptote. My horizontal asymptote is, since they're the same, I have the same degree, or the same, what did I call it? Yeah, I called it degree. Same degree, same exponent. So it's just the leading coefficient. So that's going to be y equals 1 over 1. Your horizontal asymptote is always y equals. So now I can come over here and do y equals 1. 1 over 1 just equals 1. And I'm going to do another example of this, so no worries. We're going to do like 4 more. So I have a horizontal asymptote at y equals 1. Horizontal is like the horizon, it runs this way. So I'm going to go to y equals 1. knee, 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 knee. Knee, 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 knee. All right. Now that I have my asymptotes, I have my vertical, I have my horizontal. All I need to do now is graph this bad boy. Do you notice that I have 4 corners here?
Yep.
Okay. They're usually, most often, in opposite corners of each other. Okay? So if you know this one's here, then you know the other one's there. Okay? All right. So this is how you do it. Last step, way down here. Go past A, B, C, D. Step number 4 says, sketch the graph, find some x values, make a table, and plug it in. Basically is what you're going to do. So you're going to do some x values. I generally like to do like x equals 0. I really like 0 or a number that I think is going to be really pretty to plug in. You can kind of eyeball it.
I'm not sure I understand.
Siri. Okay. All right. The other way of finding a number, and this is new, this is not on mine, but it's on your other paper, is to find your x-intercept. That's a point, right? Your x-intercept. And the way to find this is to set your numerator equal to 0 and solve for x. So I like this method too. So you just have to find 2 more points. One of them, probably just going to be plugging it in. The other one, I like to find the x-intercept. You set your numerator equal to 0 and solve for x. So if you will follow these 4 steps, you'll be able to get through the whole problem. Whew. I know the first one's always tough, but it does get much easier, I promise.
That wasn't that hard.
All right, ready? Here we go. So now that I have all this, all I need to do is find some points. So look up here. My last one, I'm just going to do number 4 up here. I need to do a table. I really like to plug 0 in. What does 0 do when I plug a 0 in for x? It makes stuff cancel. Makes it go away, right? So I want you to plug a 0 in. So if we plug 0 in right there, I'll have y equals 2 times 0 minus 6 all over 0 minus 1. Doesn't it just make all of that go away? And what am I left with? Negative 6 over negative 1, right?
Yeah.
That goes away, that goes away. I'm just left with negative 6 over negative 1. That's why I like using 0. It's easy. So what does that give me? What's my answer? 6. So 0, comma 6 is an ordered pair. 0, 6. So graph 0, 6. Perfect. You only need 2 points to graph. That's it. So I started here. Make sure you start at your origin. And I went 0, 6. Now, here's the cool thing about asymptotes. Your graph is going to want to approach and get really, really, really close and then turn, okay? So all I have to do is draw a smooth L-shaped graph approaching my asymptotes. And there you go. Do not make this look like a hiney. Some of y'all like that dot right there, and you like to do like a little like hump. Okay? Please do not do that. It is a smooth curve, okay? So make sure it is a smooth L-shaped curve, okay? Now, do y'all know how I got that point? To find any ordered pairs, you just plug an X in to the equation, and it spits out a Y. The other one I like to do is the x-intercept. So your x-intercept, come over here. That's going to be our other point that we do. All you have to do is set the numerator equal to 0. So 2x minus 6 equals 0. What does x equal? So you just set your numerator equal to 0. That gives you an x-intercept. So I solved it. I got 3. Well, that's an x-intercept. That means it's on the x-axis. So I go over 1, 2, 3. There's my other point. Easy enough?
Yeah.
So that's the way you're going to do your 2 different points. So 1, 2, 3. There we go. Just curve it, and you were done. Perfect. If there was a hole in this graph, you would have to go back to the hole and erase it and put a hole there. That's it. Okay? All right, let's try another horizontal asymptote.
That's it.
That's it. You're done. All right, and we're taking a lot of time doing it, but it really doesn't take that much time. All right, come on over here. All right, back to this paper. Let's go. Hop, 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 hop. Come on.
I got it.
All right, what we just did was this. If the degree of the numerator is equal to the degree of the denominator, okay? Now, it says, how do you find that? It is the leading coefficients of the top and bottom. All right, so I'm going to come over here. Since the degrees are the same, the exponents are the same, then my horizontal asymptote, y equals, is going to be the leading coefficients of the top and the bottom. So what's my horizontal asymptote going to be here? 3 over 1, which is just 3. So that's what we just did. That's the type of horizontal asymptote we just found, okay? All right, I'm going to do one more fantastic example with you. And let's make it, let me see.
Wait, so if you got, let's say you got 3x.
Number 8. Huh?
Let's say you got 3x and 2x.
Then it'd be 3 halves, 1.5. Good question. All right, number 8 is our last example. All right, number 8. Let's do number 8, and then you guys are going to work on your homework, okay? All right, here we go, here we go. Look at number 8. Isn't that a doozy? Okay, so what do you think? Look, flip your paper over and tell me what step number 1 is. Flip your paper over, step number 1. Whoa, that got really dark. Hey, is that better? All right, here we go. Factor, factor, factor. Step number 1. I want you to factor and cancel. See if there's a hole in the graph. All right, factor. Here we go. How do I factor the top? X method. Thank you. I'm going to come over here. I know that my telephone can pick up every single conversation, so I'm not sure what was just said, but it can pick up every single conversation. Okay. All right, here we go. Not funny if I just recorded this entire thing and it's not, and I'm going to have to delete it. All right, so here we go.
It's not bad.
X method. Here we go. X method. So, and I can do the shortcut X method, which, by the way, on your test on Friday, some of y'all used the short X when you couldn't use it, when you should have done factor by grouping and you didn't, okay? So make sure you're paying attention. All right, what multiplies give you negative 28 and adds to give you 3? 7 and negative 4. Thank you. Shh, write it down. Finish. Come on. All right, go to the denominator. Short X method. I'm not sure if you can even see that with the lights on. I think I'm going to have to turn the lights back on. Sorry. Sorry, not sorry. Ah! Sorry, I don't know which one my phone picks up better. All right, so here we go. So we have 35 and 12. What is it?
24.
What multiplies to give you 35 and adds to give you 12?
7.
Yeah, 5 and 7.
Was that really right?
Yeah.
I'm so smart.
Okay, now that it's factored, that's what step 1 says to do. Factor and cancel if possible. If you can cancel, you get a hole in the graph. Am I going to have a hole?
Yep.
I'm going to have a hole at, what's canceling?
7.
So x plus 7 equals 0. So where's it going to be at? X equals negative 7.
I think your ears look like blow up or something.
No, that's just the heat coming on.
Oh.
Okay, at x equals negative 7, I'm going to have a hole in the graph at x equals negative 7. Do y'all see why? Something canceled, there's a hole in the graph, okay? Now, notice what's left. The only thing that's left here is this. Notice that the leading coefficients, they have the same degree, right? X to the first, x to the first. Okay. So what is step number 2? Step number 2. What's it say? Find the vertical asymptote, set your denominator equal to 0 and solve. All right, so vertical asymptotes are up next. Okay, what am I doing?
Hold up.
Okay. What am I supposed to do for a vertical asymptote?
Say it equals 0.
Set your denominator equal to 0. It's no longer this. It doesn't have this anymore. This is the only thing that's left. So it's going to be x plus 5 equals 0. So x equals negative 5. So my vertical asymptote is at x equals negative 5. So let's go ahead and graph that bad boy. Here we go. Go to negative 5. All right, so I have that one done. Horizontal asymptote is next. You're not sure where to go? Come back to this paper. Step number 3, to find the horizontal asymptote, look at the degrees. This is what we have going on. The degree of the top is equal to the degree of the bottom. Look at it. The degree of the top is 1. The degree of the bottom is 1. They're equal to each other. So what do I do? How do I find the horizontal asymptote? All right, it's going to be the leading coefficients. How do I know that? Because I looked at my paper. The degree is equal to the degree, top and bottom, leading coefficients. So what are my leading coefficients?
1 and 1.
Yep, just 1 over 1, so it's just 1. Y equals 1. Good job, good job. So I've got to do y equals 1. Okay, so now I have to graph, and I have to come up with 2 points. So make a table, step number 4, sketch the graph, find an x value to the left and to the right of the vertical asymptote, make a table, plug it in, find an answer. So here we go. Now I need to make a quick table. So I can do this, and I can also use my x-intercept. Let's go ahead and find my x-intercept. You need 2 points. This is one of your points. How do you find your x-intercept? Set what?
Set your numerator equal to 0.
Thank you. Set your numerator equal to 0. So we have x minus 4 equals 0. So x equals 4, which is really just an ordered pair. Set your numerator equal to 0. My numerator is x minus 4. You get 4 back. It's on the x-axis. So go to 4 comma 0. That'll be one of our points. Way over here. And remember, we're drawing it as a smooth L-shaped curve. No lumps or bumps. There we go.
I accidentally drew a bump in mine. Oopsies.
Okay, now I need to come up with another x value. It's in, if you look at my 4 corners, it's in the bottom right. So I know my other one's going to have to be in this upper left. So I need to pick one of these numbers over here. And I picked -6 in the last class, and it seemed to work out very well. So why don't we use -6? Okay, you could pick -6, -7, -8, -9, -10. 10 was a good number too, I think. But anyhow, why don't we do -6? So down here, now that I know what my x-intercept is, I got to pick another number that'll work. So I'm going to come over here and plug in -6. So I get -10 all over -1, so 10.
Where did -6 come from?
You can pick any number in the graph. Any number. So look, I know that I have one curve there. So I know the other curve has to be on this side of the left, or the asymptote. See the vertical asymptote? I've got to pick some sort of x value on the other side of the asymptote. They're in opposite corners of each other. So I can't pick any of these numbers. I've already drawn that curve. So I need to pick a number over here somewhere, an x value, any x value. It doesn't matter. You pick your own x value and plug it in. So This asymptote's at -5, so I need to pick -6, -7, 8, 9, or 10, some number over this way, find an ordered pair, and plot it. So you pick whichever number you want. I picked -6 because I did it before and it was easy. Okay? So you pick whatever number. You just need to make a table. Pick an X. You choose that. I chose -6. Then I plugged it in to my equation. And when I plugged it in, I ended up getting -10 over -1, which is 10. So this is my other ordered pair that I get to graph, -6, 10. Yes, sir.
This is like a -6 and -4, like under the Y. Where did you get that from?
See that equation? I took
Oh.
-6
Yeah, you plug in that.
and I plugged it in there. And then I plugged in -6. Now you get to choose what that number is. I don't care what X value you choose, but there's no sense in choosing an X value over here because I've already graphed over here. You need to choose an X value that way because I don't have my L over that way. Okay? So now I'm going to go to -6 and go up to 10, and there's my other point. Draw your curve, approach your asymptotes, and you're done. Almost. What am I missing? One thing missing. A hole in the graph.
Oh my gosh, Gracie, I'm so proud of you.
Thank you. Don't forget your hole in your graph. You have a hole in the graph at -7. So I'm going to go, this is -5, -6, go to -7, and then go up to your graph. Boom, right here. I have a hole in my graph at -7.
What points did you use to graph that one where you just put the hole on?
Well, I knew that I had a hole at -7. So I went back to -7,
So it
and then I just went to my graph, wherever my graph was. If my graph was up, I'm traveling up. I'm going to find my graph, and here's my graph, right?
How do you know if it's up?
Because that's the only place that curve is. If I went -7, went down, there's no graph down here, there's no graph down here, there's no graph down here. I'm going to -7, and then I'm going to go find my graph.
And as soon as you touch your graph.
As soon as you touch your graph, put a hole there. That's it. As soon as you touch your graph, put a hole there. If you want to know exactly where it's at, plug -7 in and see what your Y value is.
What do you mean by touch the graph? That's confusing.
Okay. It,
Small.
if I told you to go to 0, where's 0 at? Right here. I need you to take the shortest distance from 0 to the curve of the graph. Not the graph paper, the actual picture that I'm drawing. Would I go up or down to get to the picture? I need to get to the curve of the graph.
You go up.
If I go up, where's the graph? Is the graph up? Where's the graph? Where's the curve? Here's the curve.
Oh, sorry. You go down.
Here's the curve. So if I tell you you're at 0 and it's like playing a game. It's like being on Nintendo. Here you are. I want you to get to the road. Here's the road. How do you go? You go straight down.
I don't know. I was thinking about the one right
If you're right here and you're at -7 and I want you to get to the road as fast as possible, you're going to go straight up. You're going to try to get to that road. That's how you go. So once you know where your hole's at, you go to that number and then you take the shortest distance to get to that road or get to the curve. Okay? All right. So last thing I'm going to tell you is domain and range, and then we'll be about done. All right. Your domain is all reals. Your range is all reals, which we love. Except, do y'all see this vertical asymptote at X? That affects my X. So X can't be -5 because there's an asymptote at -5.
And
My range,
can't be negative.
that's right. See, my range is Y values, and so it can't be -1.
That mark is
Negative
up.
1 or 1.
Yeah, -1, +1. You're right. It does not
I
work.
said it wrong the first time.
Very good.
My
Sorry.
bad.
All right, so now listen. Tonight, you are going to do numbers 1, number 2, and number 3. I want you to fill in as much as you can in the blanks. What you don't know, we can go over tomorrow before we start the rest of the lesson, okay? So your job tonight is, listen, when I hand out the homework, you're doing numbers 1, 2, and 3. That's it. You have 3 problems. Good? All right, I'm going to put it on the front table for you.